to our introduction on integers. The first thing we want to know is how do integers fit in with all the rest of the numbers that we already know and talk about. So when you first started learning about numbers, the first thing you would have talked about would have been things called natural numbers. And natural numbers are the things we count with. 1, 2, 3, when you're counting objects, those are the first things we introduced. And then when we went a little bit further, you might have also started talking about 0. 0 is the next biggest number. And so this is a Venn diagram where the inner circle, everything in that belongs to the next circle. So all natural numbers are whole numbers. The only whole number that's not a natural number is 0. And then through math education, you actually skipped over the integer circle and went right to the rational number section. And this is where all your fractions and decimals live. So all the fractions and decimals that can be written as a fraction. So the word ratio sits inside of rational numbers, and that's what they have to be. They have to be able to be written as a fraction, a over b. We won't talk too much about irrational numbers over here, but irrational numbers are square roots that don't work out, numbers like pi, or decimals that continue on forever but don't repeat a pattern. So let us return to integers. You may already know that integers have something to do with negatives. So negative 2 is an example of an integer, negative 5 is an example of an integer, but also our positive numbers like 9 is an integer and 0 is an integer. It includes all of the whole numbers, now all of the negatives as well. We also have here the square root of 49, and the square root of 49 is 7. In a later time we can talk about why it's also negative 7. So let's go ahead and define integers as the set of all positive and negative whole numbers. Some characteristics that are true about our integers is that we have no fractions or decimals, and we can also kind of describe that they all have a sign, kind of a direction. What would we say for some examples? Some examples of our integers, certainly something like negative 5, negative 2, but also positive numbers like 3 or 0, maybe even the square root of 36, because that's 6, or negative 6. But non-examples would be 3.2, even negative 5.8, or 5/6, or the square root of 2, or 1.7 repeating. All of these would be not integers. Just a little bit below, let's take a look at the number lines we have here. Number lines can be oriented both vertically and horizontally. So you notice, of course, that the numbers that we're familiar with, the positive numbers, are increasing as we go to the right, and we see them going up 1, 2, 3, 4, 5. The negative numbers are on the other side in kind of mirror image. So we see negative 1, negative 2, negative 3, negative 4, negative 5. We will talk that even though the numbers kind of appear to be getting bigger, like 5, that's actually a smaller number than negative 4. So it's still always true that as we go to the right, we're getting bigger numbers. And as we go to the left, of course, we're getting smaller numbers. We can orient it vertically, kind of like a thermometer. The higher up we go, the larger the number is. The further down, the smaller the number we get is. Okay, so let's go ahead and talk about some applications of negative numbers in real life. So it says the Weather Channel is forecasting that Monday the overnight temperature will be negative 4 degrees, and on Tuesday the overnight temperature will be negative 6 degrees Fahrenheit. So between those two, which is colder? So we can think about which is furthest left on the number line, and that is going to be the negative 6 degrees Fahrenheit on Tuesday. And if we think about which one has the higher overnight temperature, that's going to be the negative 4. So negative 4 is warmer, of course, than negative 6. Okay, question 2, the day temperature, mean the temperature during the daytime on January 9th in Calgary was negative 17 degrees Fahrenheit, and in Edmonton it was negative 9 degrees Fahrenheit. Which temperature was the furthest from 0? Well, that was Calgary at negative 17. Vancouver's temperature was in between Calgary and Edmonton's. What are some possible numbers it could have been? It could have been negative 16, that's in between. It could be negative 14, negative 12. Certainly negative 15, negative 13, negative 10, all of these numbers would be in between those two values. After 2 terrible losses on Sunday, the quarterback for Baltimore had negative 12 yards rushing, and the quarterback for Cleveland had negative 8 yards rushing. Which quarterback had a better game? Well, they both had bad games. We can always hope so. But the quarterback from Cleveland had the better game. He was minus 8, but that's still better than minus 12. To cancel out their performances, the Baltimore quarterback would need 12 yards. So that's kind of informing you that the opposite of negative 12 or positive 12 would counteract that, and same thing, 8 yards would undo that negative 8 there. Okay, so let's take a look about golf. If you know a little bit about golf, par is what average is, and so the scores are kind of above and below average is how they're kind of evaluated. So after the first day of golfing, Phil has a score of negative 5. How many fewer strokes did Phil need than the average golfer? He needed 5 fewer strokes. After 3 days of golfing, Phil had scored a score of negative 12, and Tiger had a score of negative 8. Who has the lowest score? So the lowest score is best in golf, and Phil had the lowest score with his minus 12. In hockey, if a player is on the ice when the other team scores, he gets a minus. For example, if a player's on the ice when the other team scores 2 goals, he'll be a -2 for the game. So, disappointing loss for the Penguins to the Bruins. Who played better? Letang was a -3 or Kunis a -5. Letang had a better game. And here you can see out-of-date problem, but Niskanen was -1 or Neal was -4. Who played worse? Neal played worse at -4. Okay, we can talk about debt as well. If you owe somebody money, that's sometimes construed as a negative. So after going on a shopping spree, Amanda's bank account is now -$1,200. Her friend Seth currently has a bank account of -$750, whose bank account has a higher balance. So they both are negative, they're both in trouble, but Seth has the better balance at -7. So who needs more money to pay off his or her debts? Well, that would be Amanda. She needs a total of $1,200 to pay off her debt. So how much money would it take to pay off all of Amanda and Seth's debts? Well, it would take $750 for Seth and $1,200 for Amanda, so it would take a total of $1,950 to pay them both off. Okay, let's look at this map of the seafloor. So here we can see here's land, here's the mean seafloor, and here's the bottom of the Mariana Trench. Over here we have as high as Mount Everest would be. So which is furthest from sea level, the Mariana Trench or Mount Everest? Well, that is the Mariana Trench. And we'll talk about this relates specifically to another concept that we're going to talk about, being the furthest away from zero. So the distance from sea level is similar to what we say absolute value. That's the mathematical term that we use for distance from zero. A big concept in the integer unit will be absolute value. The absolute value of a number is the distance it is from zero. So for instance, the absolute value of 4, if we look at the number line to help us, here's 4, so that's the distance 4 is from 0, which is 4 units. If we look at -3, here it is on the number line. How far is it from 0? It is 3 away, so its absolute value is 3. Now we don't usually write out the whole word absolute value, we have some notation to help us write this. So to write the absolute value of 4, we use these vertical bars around it. That says the absolute value of 4. Absolute value of 4, as we said, is equal to 4. And to write the absolute value of 3, we write absolute value -3. So let's practice here. Absolute value of -9 means the distance of -9 is from 0, and that's 9. Absolute value of 11, 11 is 11 away from 0. Absolute value of 15, 15, it's 15 units away from 0, and -20 is 20 units away. So positive numbers do stay positive, and negative numbers do turn positive. Now we can conclude that the absolute value, the greater the absolute value of a negative number, the smaller it is. So what does that mean? So if we think about -20, for instance, its absolute value is 20. That's bigger than, for instance, 9. So if we're comparing -20 and -9, -20 has a greater absolute value. So it is smaller than -9. So here if we look at these numbers here, we're looking through the list of numbers, and we're going to look for the number that's negative with the greatest absolute value. So I see -11, and then the next one would be -6, -4, -3, and then we're out of negative numbers, so we have 0, we have 2, 11, 15, and then 20. We're going to skip over this modeling integer addition. There's more of this later in the packet. Hello again. In this lesson, we're going to be ordering integers and other rational numbers. So we're going to be looking at them on a number line to start. So the first thing we're going to do is we're going to graph the number 7 and its opposite. So 7, of course, is here. We're just going to graph it by putting a point there. And its opposite would be -7. Great. Let's also graph 5 and its opposite. So there is 5, and its opposite, -5. It's good to just get a visual on where these numbers fall. But let's dig a little deeper. Where does 7 lie in relationship to 5 in the number line? Well, if we look at 7, we look at 5, 7 lies to the right. Where does the opposite of 7 lie on the number line in relation to the opposite of 5? So the opposite of 7 and the opposite of 5. So the opposite of 7 lies to the left of the opposite of the opposite of 5. So let's try to generalize this. If I'm thinking of two numbers, and the first number lies to the right of the second number on the number line, what can you say about the location of their opposites? Well, the same kind of path is going to follow here. If the first number is to the right of the second number, the opposite of the first number is left of the opposite of the second number. And so this we can extend to talks about absolute value as well. So when you take the absolute value of something, of a negative number, its value could be less. The more negative a number is, the greater its absolute value, even though it is less negative. So they have kind of an inverse relationship there. As you get more negative, you get less value. Okay, so in example 1 it says the record low temperatures for a town in Maine for January are -20 degrees Fahrenheit and February -19 degrees Fahrenheit. It says order the numbers from least to greatest. So we can apply that now to think about the least number. So if it's the least, it is the smallest. So negative 20 here, then negative 19. That's kind of the reverse of the order that we're used to seeing 20 and 19, but this is their opposites. 19 would be smaller than 20, but the opposite of 20 is smaller than the opposite of 19.
To further our understanding of the ordering of integers, we are going to spend some time graphing rational numbers, which does include integers and some negative fractions as well. So we're going to go ahead and look at a number line, and we're going to try to figure out where negative fractions are on that number line. These two paragraphs here are like the kind of convoluted way of kind of saying how we would go about, graphing a fraction on a number line. So if we're trying to graph the point 310 here on this number line, the first thing we're going to want to do is use the denominator to determine how many spaces we're going to break this thing into. So we'll go ahead and cut it in half there to help me, and 1, 2, 3, 4 lines there, 1, 2, 3, 4 lines there. So that'll cut it into 10 pieces altogether. This is our halfway mark, and so we're counting by tenths, so that's 1/10, 2/10, 3/10. So there's our point 3/10 that we were looking for, but let's also try to graph its opposite on the number line. So that's going to be on this side. So there's kind of our halfway point. We'll put 1, 2, 3, 4, and 1, 2, 3, 4 points over there. So this is negative 1/2, and these are negative 1/10 each. So that's negative 1/10, negative 2/10, negative 3/10. So here we can see this point is negative 3/10, and you can kind of think about how far away it is from 0 on this side versus how far away 3/10 is on the other side. Okay, so here we've got another example. We're asked to find negative 7/4 and its opposite on the number line. So let's go ahead and start with that. All right, so I'm going to go ahead and throw 0 maybe here, and let's count by fourths. That'll help us get to 7/4. So 1/4, 2/4, 3/4, 4/4, or 1, 5/4, 6/4, and 7/4. So we'll plot a point there. That's actually the opposite we went with first. We go over here, we have negative 1/4, negative 2/4, negative 3/4, negative 4/4, negative 5/4, negative 6/4, negative 7/4. So there's our other point. So now we can kind of see how these points are actually the same distance away from 0. They're on opposite sides of the number line. So here they're kind of helping us and guiding us. They're saying on the number line each sigma represents 1/4, and the fraction is located between. So negative 7/4 is located between. You can see here is negative 1, and the next one would be actually negative 2. That would be negative 8/4. So between negative 1 and negative 2.